Tonight, I find myself remembering the quiet fermentation chambers of ancient Japan, the way humid air carried the scent of Koji spores through wooden brewing halls, and how the patient rhythm of seasons shaped every drop of liquid gold we call soy sauce. This is history as it was lived, hurried, fermented, real. If this quiet approach to culinary heritage helps you unwind, a like would mean a lot. Subscribe if you'd like to join me for more slow journeys through food history. Tell me in the comments where tonight finds you listening and what draws you to these ancient kitchen mysteries. Dim the lights. Let's drift back to the first Chinese workshops where salt met soybeans in sacred marriage. I remember the weight of salt in those ancient Chinese hands, how each crystal caught the weak light filtering through bamboo shutters in the Zhou dynasty workshops. Back then, 2,000 years before our modern conveniences, salt was not something you reached for carelessly on a shelf. It was white gold, precious beyond measure, traded grain by grain across impossible distances on the backs of camels and in the holds of river barges. The morning mist would rise from the yellow river valleys, and in the dim workshops of the early fermentation masters, you could hear the slow, methodical grinding of stone mortar. Workers bent over their tasks, crushing soybeans that had been deemed inedible by mustard, bitter things that seemed to mock the stomach rather than nourish it. But these patient craftsmen had discovered something the rest of the world had missed. They had learned to wait. I can still sense the musty dampness of those storage rooms where wooden vats lined the walls like sleeping giants. The air hung thick with the scent of transformation, not pleasant exactly, but rich with possibility. This was where Jing was born, that ancient fermented paste that would become the ancestor of everything we now pour from bottles and savor in bowls across the world. The earliest Jing bore little resemblance to what we might recognize today. Picture instead a chunky, paste-like mixture where chopped meat played the starring role. Fish scraps, too, and various grains that had been deemed suitable for this slow alchemy. The soybeans were there, yes, but as supporting players in a more complex drama. The paste was dense, almost chewy, something you might spread rather than pour, something that carried the concentrated essence of protein and salt in every spoonful. Those ancient fermentation masters understood something profound about time and transformation. They knew that what seemed indigestible, those hard, stubborn soybeans, could be unlocked through the patient work of beneficial microorganisms. The beans would soften, their tough cellular walls breaking down, their proteins unraveling into forms the human body could embrace and use. I remember how the workshops smelled in the early morning hours when the fermentation was most active. There was a barnyard quality to the air, not unpleasant, but alive, the scent of things breaking down and building up simultaneously. The workers would move between the vats with wooden paddles, stirring carefully, reading the bubbles and foam like ancient texts, written in a language only they understood. Salt was the crucial guardian in this process, the expensive element that made everything possible. Without enough salt, harmful bacteria would invade and turn the whole batch putrid. With too much, nothing would happen, and all the beneficial microorganisms would lie dormant. Unable to begin their transformative work, the salt created a selective environment, a microscopic ecosystem where only certain organisms could thrive. The Zhou dynasty workshops were places of quiet expertise, where knowledge passed from master to apprentice through demonstration rather than written instructions. The proper ratio of salt, to protein, the ideal temperature for fermentation. The signs that indicated success or failure, all of this lived in the hands and noses and eyes of the craftsmen. They would test the developing paste with wooden spoons, rolling small amounts across their tongues, reading the progression of flavors like a story unfolding across weeks and months. As dynasties rose and fell, as the Han gave way to the Tang and the Tang to the Song, the art of jing making evolved with the subtle persistence of all living traditions. The meat began to play a smaller role, while soybeans asserted themselves more confidently in the mixture. This was not a sudden revolution, but a gradual shift, driven perhaps by economics. Meat was expensive. Beans were relatively affordable, but also by the growing understanding of how soybeans responded to fermentation. By the time the Song dynasty had established itself, roughly 1,000 years ago, something remarkable was happening in the fermentation vats. Observers began to notice a dark liquid collecting on the surface of the aging jingye, a kind of essence that seemed to concentrate all the flavors of the paste below. This liquid had a different character, entirely thinner, more penetrating, with a capacity to enhance other foods rather than compete with them. The Song dynasty scholars, with their characteristic attention to detail, began to document this phenomenon. In their cookbooks and household manuals, you can find the first mentions of jingyo. Literally, the oil of the jingyo. They described it as a precious extract, something to be collected carefully and used sparingly, like a concentrated medicine for food. I can picture those Song dynasty kitchens, more sophisticated than their predecessors, where cooks began to experiment with this dark liquid. They would drizzle small amounts over steamed vegetables, discovering how it could awaken sleeping flavors. They mixed it into marinades for meat, watching how it seemed to tenderize and enhance in ways that salt alone could not achieve. They added drops to soups, witnessing the transformation that occurred when the liquid met hot broth, how it bloomed and expanded, filling the entire bowl with its complex aroma. The fermentation halls of the Song period were larger, more organized than the simple workshops of earlier dynasties. Rows of ceramic vessels replaced some of the wooden vats, and the processes became more standardized. But the essential magic remained the same: the patient marriage of soybeans, salt and thyme, overseen by craftsmen who understood that you could not hurry transformation. The workers in these halls developed an intimate relationship with their fermenting batches. They could tell by the sound of bubbling whether fermentation was proceeding properly. They could read the color changes that indicated different stages of development. They knew when to stir and when to leave undisturbed, when to add moisture and when to allow natural evaporation to concentrate the flavors. The transition from the thick, chunky jing to something more liquid was not immediate. For centuries, the paste remained the primary product, with the liquid being collected as a valuable byproduct. But as trade routes expanded and urban populations grew, there was increasing demand for condiments that could travel well, that could be stored for long periods without spoiling, that could enhance simple foods without overwhelming them. The Chinese merchants who carried goods along the Silk Road began to recognize the value of this concentrated liquid. Unlike fresh foods that spoiled quickly in the desert heat, unlike even the fermented paste, which was bulky and difficult to transport, this dark extract could survive long journeys while maintaining its potency. It became a luxury item, sought after by wealthy households in distant cities who had heard rumors of its remarkable properties. I remember the careful way these early bottles were sealed, with layers of wax and cloth, protecting their precious contents from air and moisture. The liquid itself was still quite different from what we would recognize today, thicker, more viscous, with a stronger flavor that required dilution before use. But it carried within itself the genetic code, so to speak, of all the soy sauces that would follow. The craftsmen of the later Song period, and then the Yuan and Ming dynasties that followed, began to refine their techniques specifically for liquid production. They learned to adjust the initial mixture to favor liquid formation. They developed better methods for separating the liquid from the solid residue. They experimented with different aging times, discovering that longer fermentation produced more complex flavors, but also required more careful management to prevent spoilage. By the 18th century, the transformation was nearly complete. What had begun as thick, chunky jing, dominated by meat and fish, had evolved into a primarily liquid product, where soybeans played the starring role. The dark, aromatic liquid that pooled on the surface of fermentation vats was no longer a byproduct, but the main event. The paste itself became secondary, valued primarily as the source of this liquid gold. The workshops of 18th century China were sophisticated operations, with multiple stages of production and quality control. The best producers had learned to create consistent products batch after batch. By controlling every variable, they could manage the quality of the soybeans, the purity of the salt, the temperature and humidity of the fermentation chambers, the timing of each stage in the process. Yet even with all this sophistication, the fundamental mystery remained unchanged. The transformation that occurred in those fermentation vats was still, at its heart, a kind of magic. Invisible organisms worked their slow alchemy, breaking down complex molecules and reassembling them into new forms. The dark liquid that emerged carried flavors that no single ingredient could provide, on its own a complexity that spoke of time and patience and the accumulated wisdom of countless generations of craftsmen. The Chinese Jing tradition had given birth to something that would eventually travel far beyond its homeland, that would adapt to new climates and new tastes, while maintaining its essential character. But that journey was still in the future. For now, in those quiet fermentation halls where steam rose from wooden vats and salt crystals dissolved into protective brines, the ancient art continued its patient work, transforming simple ingredients into liquid complexity, one slow day at a time. The workers would go home in the evenings, leaving their charges to continue the invisible work of fermentation. In the darkness, beneficial bacteria and yeasts carried on their eternal dance, breaking down proteins and starches, creating the foundation for flavors that would eventually grace tables across the world. The salt stood guard, protecting the developing liquid from harmful invasion, while time itself became an ingredient as crucial as any soybean or grain of salt. This was the beginning, not dramatic or sudden, but gradual and persistent. Like all the most important transformations in human history, in those ancient Chinese workshops, in the marriage of soybeans and salt and thyme, the first chapter of soy sauce was being written, one fermented day at a time. I remember the mountain mist that clung to the temple walls of Koji in the year 1254, how it drifted between the wooden pillars like incense smoke, carrying with it the scent of cedar and stone and something else, something that would change the course of culinary history. The Zen priest Kakashi had returned from his long journey to China. His robes, still holding the dust of distant roads, his mind heavy with new knowledge and his hands remembering techniques that had no Japanese names. The temple bells would ring at dawn across the valleys of Keshu, their bronze voices echoing off the steep mountainsides that surrounded the village of Yuasa. In those early morning hours, when the world seemed suspended between sleeping and waking, Kyokushin would walk the stone paths of his temple, contemplating the teachings he had absorbed during his years at Chinese monasteries. But increasingly, his thoughts turned to more practical matters: the fermentation techniques he had learned, the recipes that existed only in his memory, the possibility of recreating in this humid Japanese climate what he had witnessed in the workshops of Song Dynasty China. The villagers of Yuasa were simple people, farmers and fishermen, who lived close to the rhythms of season and tide. They knew little of the wider world beyond their mountain valleys, and when the learned priest began to speak of fermented pastes and exotic preservation techniques, they listened with the polite attention due to a holy man, but with little real understanding of what he was proposing. Kyokushin's hands were not the soft hands of a scholar who had spent his life only in contemplation. During his years in China, he had worked alongside the fermentation masters, learning through touch and smell and taste the subtle arts they practiced. He remembered the weight of soybeans in his palms, the way salt felt between his fingers, the particular consistency of properly prepared koji. These sensations lived in his muscle memory, waiting to be awakened in this new land. The climate of Kyushu province was different from anything Kyokushin had experienced in China. The air held more moisture, hanging thick and heavy around the mountain slopes. The seasons moved with their own particular rhythm submerse that seemed to breathe humidity. Winters that were gentle compared to the harsh cold of northern China. He wondered if these differences would affect the fermentation process, if the invisible organisms that worked their magic would adapt to these new conditions or reject them entirely. In the temple's modest kitchen, Kyokushin began his first experiments. He had carried no written recipes from China such. Precious knowledge was not committed to paper, but lived in the hands and hearts of the masters who shared it. Working from memory, he attempted to recreate the kinzanji miso he had learned to make, that complex fermented paste that combined soybeans with vegetables in a slow transformation that could take months to complete. The first challenge was the soybeans themselves. Japanese soybeans were smaller than their Chinese cousins, with a subtly different flavor profile. Kyokushin spent hours examining them, rolling them between his fingers, tasting them raw to understand their character. He cooked small batches experimentally, adjusting the steaming time until he achieved the texture he remembered from his Chinese training. I can picture him in those early days, working alone in the temple kitchen while the other monks went about their traditional duties. Steam would rise from the cooking pots, filling the room with the earthy aroma of soybeans transforming under heat. He would test the beans constantly, pressing them between his fingers to judge their tenderness, watching for that perfect moment when they yielded to pressure but still maintained their shape. The vegetables posed their own challenges. The Chinese recipe called for specific varieties that simply did not exist in Japan, forcing Kyokushin to experiment with local alternatives. He tried different combinations of eggplant and cucumber, white melon and ginger, adjusting proportions by instinct and memory. Each batch was a small act of faith, a belief that the fundamental principles of fermentation would prove universal even when the specific ingredients differed. The Koji preparation was perhaps the most critical step and the one where Kikuchin's training proved most valuable. He knew how to recognize the proper consistency of steamed rice, how to judge the temperature that would encourage beneficial mold growth without creating conditions for harmful bacteria. His hands moved with quiet confidence as he inoculated the rice with Koji spores, creating the enzyme-rich starter that would drive the entire fermentation process. In the humid air of Kishu, the Koji seemed to respond even more enthusiastically than it had in China. The white, thread-like mycelium spread across the rice with surprising vigor, creating dense mats of beneficial mold that gave off their characteristic wine-like aroma. Kikuchin watched this development with fascination, wondering if the Japanese climate might actually prove superior for certain aspects of fermentation. The village women came to watch, sometimes curious about these strange activities taking place in their temple. They observed as Kikuchin combined the Koji with salted soybeans and vegetables, mixing everything in large ceramic crocks that he covered with weighted wooden lids. The mixture looked unpromising, at first chunky and brown, with an aroma that was more challenging than appealing. The women exchanged glances that suggested polite skepticism about their priest's unusual hobby. Kikuchin arranged his fermentation crocks in the coolest part of the temple's storage area, where temperatures would remain relatively stable throughout the changing seasons. He marked each crock with the date of preparation, knowing that the transformation he was seeking would require patience measured in months rather than days. Then began the long wait, punctuated by regular visits to check the progress, to stir when necessary, to adjust conditions as the fermentation evolved. The first few weeks brought familiar changes. The initial harsh odors mellowed into something more complex and promising. The vegetables began to soften and integrate with the soybean paste. The color deepened gradually, taking on the rich brown tones that indicated proper development. Everything seemed to be proceeding as Kikuchin remembered from his Chinese training, adapted successfully to this new environment. It was during the third month of fermentation that the discovery occurred. Kikuchin had come to check on his crocks as part of his daily routine, lifting the wooden lids to examine the surface of each batch. In several of the containers, he noticed something unexpected. A dark liquid had begun to collect at the bottom of the crocks, seeping out from the solid paste above. At first, he thought this might indicate a problem with the fermentation, perhaps too much moisture or an imbalance in the salt content. But when he dipped a wooden spoon into the liquid and tasted it, his expression changed completely. This was not a sign of failure, but of transformation. The liquid had a clean, penetrating flavor that was entirely different from the paste above it, more refined, more concentrated, with a complexity that seemed to enhance rather than compete with other tastes. The discovery was purely accidental, a happy convergence of Japanese climate and Chinese technique that had produced something neither culture had intentionally created. The humid mountain air of Kishu, so different from the drier conditions of Chinese fermentation workshops, had encouraged a different kind of transformation. The same basic process that produced Kinzanji miso had, in this new environment, generated something additional, a liquid extract that would eventually become known as tamari. Kikuchin spent weeks studying this phenomenon, tasting the liquid as it developed, noting how its character changed over time. He found that longer fermentation produced more liquid with deeper, more complex flavors. He experimented with different techniques for collecting the liquid, discovering that gentle pressing of the paste could increase the yield without compromising quality. Word of the priest's discovery spread slowly through the mountain villages. The local people, initially skeptical of this strange fermentation project, began to taste the mysterious dark liquid and recognize its potential. Unlike the chunky miso paste, which required careful preparation and storage, this liquid could be used directly as a seasoning. A few drops could transform simple vegetable dishes, adding depth and richness that salt alone could not provide. The practical advantages were obvious. The liquid traveled well, stored easily, and concentrated flavor in a way that made it valuable for trade. Mountain communities like Yuasa, somewhat isolated from major commercial centers, were always interested in products that could provide economic opportunities. This accidental discovery seemed to offer exactly that kind of potential. Kikuchi began teaching the technique to selected villagers, sharing the knowledge he had gained through his Chinese training and Japanese experimentation. The process was complex enough to require skill and attention, but not so difficult that ordinary people could not master it with proper instruction. The basic ingredients soybeans, rice, koji, salt, and vegetables were readily available in rural Japan. The first commercial producers in Yuasa were families who had learned directly from Kikuchi or from his early students. They adapted his temple-scale methods to larger operations, developing techniques for managing multiple batches simultaneously. The village began to develop a reputation for this unusual product, attracting traders who carried the dark liquid to markets in nearby towns. I remembered the excitement in those early years, the sense that something significant was taking shape in this quiet mountain village. The fermentation workshops of Yuasa began to specialize, focusing more and more on liquid production rather than the traditional paste. They discovered that certain modifications to the original recipe, adjusting the ratio of soybeans to vegetables, changing the pressing techniques, extending the fermentation time, could increase the yield of liquid while improving its quality. The success at Yuasa inspired experimentation in other parts of Japan. Buddhist monks at different temples, hearing of Kikuchi's discovery, began their own fermentation projects. Some achieved similar results, while others developed variations that reflected their local conditions and ingredients. The basic principle that Chinese fermentation techniques could be adapted to Japanese conditions with remarkable results proved to be widely applicable. By the late 13th century, the production of tamari had evolved from Kikuchi's accidental discovery into a recognized craft practiced in multiple locations across Japan. The liquid had acquired its own name, distinct from the miso paste from which it originated. Recipes were refined and standardized, though still passed down through demonstration rather than written instruction. The temple at Yuasa became a pilgrimage site of sorts for those seeking to learn the fermentation arts. Kikuchi, now elderly, continued to teach interested students, sharing both the practical techniques and the philosophical approach that had made his discovery possible. He emphasized the importance of patience, of working with natural processes rather than trying to force them, of understanding that the best transformations often occurred when conditions were allowed to develop in their own time. The dark liquid that collected in those first experimental crocks had opened a door to possibilities that no one had anticipated. What began as an attempt to recreate Chinese miso in Japanese conditions had become something uniquely Japanese, a product that would eventually influence cuisines far beyond the mountain valleys where it was born. The happy accident in Kyokushin's temple had set in motion a chain of developments that would continue for centuries, carrying the essence of that first discovery into kitchens and workshops around the world. In the quiet evenings, when the temple bells had finished their daily calls and the mountain mist began to gather again around the wooden buildings, Kyokushin would sometimes visit his fermentation crocks. He would lift the lids carefully, breathing in the complex aromas that rose from within, marveling at the mysterious processes that continued even in darkness. The transformation was never truly finished. He had learned simply reached points where human patience chose to intervene, capturing particular moments in an ongoing dance between ingredient and time, climate and technique, accident and intention. I remember the moment when the invisible world became visible, when the microscopic heroes of Japanese cuisine were finally given names and recognition. For centuries, the brewers and fermentation masters had worked with Aspergillus oryzae without knowing its scientific identity, calling it simply Kojikin, the magical substance that transformed simple ingredients into liquid gold. They knew its personality, intimately its preferences for temperature and humidity, its timing, its moods, but they had never seen its true form until the lens makers and scientists of the modern age made such seeing possible. In the quiet laboratories of 20th century Japan, researchers bent over microscopes, adjusting focus until the hidden architecture of fermentation revealed itself. What they discovered was breathtaking in its complexity, at a single organism working alone, but entire communities of microscopic life, each playing its part in the slow transformation of soybeans and wheat into soy sauce. At the center of this invisible drama stood Aspergillus oryzae, so crucial to Japanese food culture that it would eventually earn the official designation of kokin, the national fungus. Picture the first moment when a scientist focused their lens and saw the branching networks of hyphal threads, like microscopic root systems, spreading through steamed rice grains. The fungus appeared as a living architecture, building itself into the very structure of its food source, creating highways and chambers where enzymes could work their alchemy. Each strand was impossibly thin, visible only under magnification, yet collectively they formed dense networks that could transform pounds of grain in a matter of days. The beauty of Aspergillus oryzae lies not in its appearance, which is rather humble, appearing as white fuzz that gradually turns greenish as it matures, but in its extraordinary biochemical capabilities. This modest organism functions as a living enzyme factory, producing an arsenal of molecular tools specifically designed to break down complex organic compounds into simpler, more useful forms. It manufactures protease enzymes that slice through protein molecules like microscopic scissors, reducing them to amino acids that our tongues recognize as umami. It creates amylase enzymes that attack starches, breaking them into sugars that feed other fermentation organisms and add sweetness to the final product. I remember learning about peptidase, another enzyme in this fungus's chemical arsenal, which works with surgical precision to cut protein chains at specific points, releasing exactly the right combinations of amino acids to create depth and complexity of flavor. Then there's pectinase, which breaks down the structural components of plant cell walls, allowing other enzymes better access to the nutrients locked inside. Each enzyme has its own specialty, its own timing, its own contribution to the grand transformation. The genius of traditional Japanese fermentation masters was their ability to manage this complexity without understanding its scientific details. They knew that Kojikin preferred certain temperatures warm enough to grow vigorously, but not so hot as to kill the delicate networks of fungal threads. They understood that humidity needed to be carefully controlled, high enough to support growth, but not so excessive as to encourage harmful bacteria. They recognized the visual signs of healthy development, the progression from bare grain to white fuzz to the slight green tinge that indicated sporulation was beginning. What they could not see, but somehow intuited, was the microscopic battle for resources taking place within each grain of inoculated rice or wheat. Aspergillus oryzae is not an aggressive colonizer that dominates its environment through brute force. Instead, it succeeds through more subtle strategies. It produces compounds that create conditions favorable to its own growth, while discouraging competitors. It forms partnerships with beneficial bacteria and yeasts that will play important roles in later stages of fermentation. It essentially engineers its own ecosystem, creating an environment where it can thrive while laying the groundwork for the organisms that will follow. The distinction between Aspergillus oryzae and its close relative, Aspergillus shōyu, became clear only through careful genetic analysis. To the naked eye, these fungi appear nearly identical. Both produce the characteristic white mycelium that fermentation workers recognize as healthy Koji development. Both generate the enzymes necessary for breaking down proteins and starches, but at the molecular level, subtle differences in their genetic code lead to variations in enzyme production and metabolic pathways that can significantly affect the final product. Aspergillus shōyu, as its name suggests, shows a particular affinity for soy-based fermentations. It produces slightly different ratios of enzymes, creating conditions that favor certain flavor compounds over others. Some traditional producers swear by shōyu strains for their ability to generate deeper, more complex umami flavors. Others prefer oryzae for its more reliable performance and cleaner flavor profile. These preferences, passed down through generations of fermentation families, represent centuries of empirical selection for traits that could only recently be explained through genetic analysis. I can picture the invisible transformation that begins when Koji spores settle onto warm, steamed grains. Within hours, the first hyphal threads begin to emerge, so small they can barely be distinguished from the grain surface itself. The spores carry within their microscopic forms all the genetic information necessary to construct the enzyme, factories that will drive fermentation. As the threads extend and branch, they begin secreting their molecular tools, starting the process that will ultimately transform simple ingredients into complex flavors. The enzyme production follows a carefully orchestrated timeline. In the first 24 hours, the fungus focuses primarily on establishing its network and beginning the breakdown of readily available nutrients. Protease activity starts slowly, nibbling at the edges of protein molecules. Amylase production ramps up as the fungus seeks to access the energy stored in starch molecules. The grain begins to soften as cell walls are breached and internal structures are modified. By the second day, the white mycelium is clearly visible, spreading across the surface of the inoculated grain like snow settling on a landscape. Beneath this visible layer, intensive biochemical activity continues. The fungus has established its primary networks and is now producing enzymes at an accelerated pace. The grain's texture changes noticeably, becoming more tender and developing the sweet, wine-like aroma that experienced Koji makers recognize as a sign of healthy development. The third day brings the most dramatic, visible changes. The white mycelium thickens and begins to show hints of green as the fungus prepares for sporulation. This color change signals that the organism has reached maturity and is beginning to produce the next generation of spores. For Koji production, this is typically the optimal harvest time when enzyme activity is at its peak. But before sporulation diverts the fungus's energy away from enzyme production, traditional Koji makers developed an intimate understanding of these timing relationships without ever seeing the fungus under magnification. They learned to read the subtle signs changes in aroma, texture, and appearance that indicated different stages of development. They understood that harvesting too early would result in insufficient enzyme activity, while waiting too long would produce Koji with diminished potency and off flavors from excessive sporulation. The controlled environment of Koji production represents one of humanity's earliest examples of biotechnology. The carefully maintained temperature and humidity conditions, the specific timing of inoculation and harvest, the selection and propagation of preferred fungal strains, all of this constitutes a sophisticated biological manufacturing process that predates our modern understanding of microbiology by many centuries. The enzyme cocktail produced by Aspergillus oryzae is remarkable for its specificity and efficiency. Each enzyme is designed to target particular molecular bonds, breaking them in ways that maximize the release of desirable compounds while minimizing the formation of unpleasant byproducts. The protease enzymes, for example, preferentially cleave protein chains at points that release amino acids associated with umami flavors, particularly glutamic acid, which gives soy sauce its characteristic savory depth. I remember learning how the fungus manages to produce such a diverse array of enzymes simultaneously without the different proteins interfering with each other. The secret lies in the organism's sophisticated gene regulation systems, which can turn enzyme production on and off in response to environmental conditions and the availability of specific nutrients. When the fungus detects high levels of protein in its environment, it increases protease production. When it encounters abundant starch, amylase production ramps up accordingly. This adaptive capability allows Aspergillus oryzae to function effectively with a wide range of raw materials. Whether working with soybeans, wheat, rice, or combinations of these ingredients, the fungus adjusts its enzyme production to match the substrates available. This flexibility helps explain why Koji-based fermentations have been successfully adapted to so many different ingredients and conditions throughout Japanese culinary history. The living chemistry happening within Koji is so complex that we are still discovering new aspects of how it works. Modern analytical techniques reveal hundreds of different compounds being produced and modified during the 3-day Koji making process. Some of these compounds contribute directly to flavor development. Others serve as precursors that will be further modified by bacteria and yeasts in later fermentation stages. Still, others function as signaling molecules that help coordinate the activities of different microorganisms in the fermentation ecosystem. The microscopic world of Koji production is a testament to the possibility of cooperation between humans and microorganisms. The fungus benefits from the carefully controlled environment and abundant nutrients provided by human producers. In return, it performs biochemical transformations that would be impossible to achieve through any other means. This partnership has been refined over centuries, with each generation of Koji makers adding their own observations and innovations to the collective knowledge. The designation of Aspergillus oryzae as Japan's national fungus represents more than scientific classification. It acknowledges the central role this organism has played in shaping Japanese food culture. From miso to sake, from soy sauce to rice vinegar, the flavors that define Japanese cuisine depend on the enzymatic capabilities of this modest fungus. Its invisible work touches nearly every aspect of traditional Japanese cooking, making it as important to the culture as any ingredient that can be seen or tasted. In the quiet laboratories, where scientists continue to study Koji, new discoveries emerge regularly. Genetic sequencing reveals the evolutionary history of different strains. Metabolic analysis maps the complex web of chemical reactions that occur during fermentation. Ecological studies explore how Koji fungi interact with other microorganisms in fermentation communities. Each discovery adds another layer to our understanding of processes that traditional craftsmen managed successfully for centuries through careful observation and accumulated wisdom. The invisible world of Aspergillus oryzae reminds us that the most profound transformations often occur beyond the reach of our direct perception. In every grain of Koji, millions of microscopic organisms work with purposeful precision, breaking down and rebuilding, creating the chemical foundations for flavors that will eventually reach tables around the world. They ask for nothing more than the proper conditions to do their work, and in return they offer the gift of transformation, turning simple ingredients into something greater than the sum of their parts, one enzymatic reaction at a time. I remember the reverence with which the old brewery masters would speak of the Hanjozo Trinity soybeans, wheat and salt. 3 ingredients so simple they could be held in cupped hands. Yet together they contained the potential for transformation that bordered on the miraculous. In the quiet moments before dawn, when the fermentation halls were still and the only sound was the gentle bubbling of active vats, these masters would sometimes pause and contemplate the elegance of this simplicity. No artificial additives, no shortcuts, no compromises, just 3 gifts from nature, combined with time and patience to create liquid complexity. The soybean stands first among equals in this sacred trinity, the foundation upon which everything else builds. I can still recall the texture of perfectly prepared soybeans beneath my fingertips, soft enough to yield to gentle pressure, yet firm enough to maintain their shape through the long months of fermentation ahead. These humble legumes carry within their cellular structure all the protein that will eventually be broken down into the amino acids we recognize as umami. Each bean is a concentrated package of potential flavor waiting for the right conditions to unlock its secrets. The selection of soybeans was never a casual decision in traditional breweries. The masters knew that different varieties would produce subtly different flavors, that beans from certain regions carried characteristics that would influence the final product. They preferred soybeans with high protein content and low oil levels, understanding instinctively what modern chemistry would later confirm that proteins would be more readily converted into amino acids during fermentation, while excessive oils could interfere with the delicate microbial processes. I remember watching the careful inspection process, how experienced hands would roll individual beans, feeling for the proper density and moisture content. Beans that felt too light might be hollow or damaged. Those that seemed too dense might contain excess moisture that could encourage harmful bacteria during fermentation. The ideal soybeans had a particular heft to them, a wholeness that spoke of proper growing conditions and careful storage. The preparation of soybeans required its own specialized knowledge. The beans needed to be soaked just long enough to hydrate their tissues without allowing fermentation to begin prematurely. The soaking water was changed regularly, preventing the accumulation of compounds that might interfere with later processes. The timing varied, with the season longer, soaking in winter's cold, shorter periods during summer's heaters. The masters adjusted their techniques to work with natural rhythms rather than against them. Steaming was the crucial transformation that made soybeans suitable for fermentation. Raw soybeans contain compounds that inhibit protein digestion, natural defenses that protect the dormant embryo within each bean. Heat destroys these inhibitors while simultaneously breaking down cellular structures, making proteins accessible to the enzymes that would soon begin their work. The steaming process required careful attention to little heat would leave the beans incompletely prepared, while excessive cooking would create mushy textures that fermented poorly. The master brewers could judge proper steaming by sight, touch, and aroma. Properly steamed soybeans had a particular translucent quality, a way of yielding to pressure that indicated complete hydration and heat treatment. They gave off a clean, nutty smell that spoke of proteins unfolding and becoming available for transformation. When pressed between thumb and forefinger, they should mash easily without being watery or sticky. Wheat plays a different but equally crucial role in the Hanjozo Trinity, contributing starches that will be converted into sugars and ultimately into the compounds that balance soy sauce's intense umami with subtle sweetness. The wheat berries themselves are first roasted, a process that develops deeper flavors while making their starches more accessible to enzymatic breakdown. I can still smell the distinctive aroma of wheat roasting in large pans, nutty and toasted, with hints of caramel and bread. The roasting process demanded constant attention and movement. The wheat berries needed to be stirred continuously to ensure even heating, preventing some from burning while others remained under-roasted. The visual cues were subtler, gradual deepening of color from pale gold to rich amber, accompanied by the release of aromatic compounds that indicated proper development. The roasted wheat would then be coarsely cracked, breaking the tough outer shells to expose the starchy interiors where Koji enzymes could begin their work. The ratio of soybeans to wheat became a defining characteristic of different soy sauce styles. Traditional Japanese Shōyu typically used equal proportions, creating a balanced profile where neither protein nor starch dominated. Too much wheat would result in excessive sweetness and lighter color. Too little would produce harsh, overly salty flavors that lacked the roundness that wheat-derived sugars provide. The masters learned these proportions through generations of experimentation, adjusting their formulas until they achieved the flavor profiles their regions preferred. Salt, the third member of this trinity, serves roles that extend far beyond simple seasoning. In the chemistry of soy sauce fermentation, salt functions as both preservative and gatekeeper, creating an environment where beneficial microorganisms can thrive while harmful bacteria are excluded. The concentration must be precise enough to provide protection and create the proper osmotic conditions, but not so much that it inhibits the fermentation organisms entirely. I remember the ritual of salt selection, how the brewery masters would examine different grades and sources, looking for purity that would not introduce unwanted flavors or minerals into their fermentation. They preferred sea salt when available, believing that its complex mineral profile contributed subtle depth to the final product. The salt was often dissolved in pure water to create brines of specific concentrations, measured by traditional methods that relied on experience rather than modern instruments. The salt brine serves as more than just a preservation medium. It becomes the aquatic environment where fermentation microorganisms will live and work for months or years. The osmotic pressure created by dissolved salt helps extract soluble compounds from the solid ingredients while preventing the growth of putrefying bacteria that could ruin entire batches. The salt concentration creates a selective pressure that favors the salt-tolerant yeasts and bacteria that contribute desirable flavors, while suppressing organisms that would create off-tastes and odors. The interaction between these three ingredients begins the moment they are combined with Koji in the fermentation vats. The enzymes produced by Aspergillus oryzae immediately begin breaking down soybean proteins into their component amino acids, while simultaneously attacking wheat starches and converting them into simple sugars. The salt brine provides the medium where these reactions can occur, while protecting the developing mixture from contamination. The balance between protein and starch breakdown becomes crucial to the final character of the soy sauce. Proteins yield amino acids that contribute umami depth and complexity. Starches provide sugars that feed fermentation, yeasts, and bacteria, which in turn produce alcohols, organic acids, and aromatic compounds that add layers of flavor. The salt regulates both processes, controlling the rate of enzymatic activity and creating conditions that favor certain types of microbial development over others. In traditional brewing, the quality of each ingredient was considered sacred because there were no shortcuts or corrections possible once fermentation began. A batch made with inferior soybeans could never achieve the depth of flavor possible with premium beans. Poorly roasted wheat would fail to contribute its full complement of sugars and aromatic compounds. Impure salt might introduce mineral off flavors or create imbalances that affected the entire fermentation process. The philosophy of minimal ingredients carried profound implications for every aspect of production. Without the option of adding artificial flavors, colors, or preservatives, every element of the process needed to work in harmony. The soybeans had to be perfectly prepared. The wheat needed to be roasted to exactly the right degree. The salt required careful selection and precise measurement. The Koji had to be cultivated with perfect timing. Any weakness in one area would be reflected in the final product. I remember learning about the concept of terroir as it applied to soy sauce production, how the same three basic ingredients could produce distinctly different flavors when processed in different regions. Local water sources affected the mineral content of the salt brines. Regional soybean varieties contributed their own flavor characteristics. Even the indigenous microorganisms present in different brewery environments could influence fermentation in subtle but measurable ways. The seasonal timing of ingredient preparation became part of the brewery's annual rhythm. Soybeans were typically prepared during cooler months when the risk of harmful bacterial contamination was lowest. Wheat might be roasted in larger batches. When weather conditions were most favorable for storage, salt brines were prepared when humidity levels allowed for proper concentration and clarification. These timing considerations reflected centuries of accumulated wisdom about working with natural processes rather than forcing artificial schedules. Modern industrial production has introduced variations to the traditional trinity, sometimes using defatted soybean meal instead of whole soybeans, or adding corn syrup to accelerate fermentation. But the fundamental relationships remain unchanged. Proteins must be broken down into amino acids, starches must be converted into sugars, and salt must create the proper environment for controlled fermentation. The three sacred ingredients continue to provide the foundation for transformation, whether in ancient wooden vats or modern stainless steel tanks. The reverence for these simple ingredients reflects a deeper understanding of the fermentation process as a collaboration between human intention and natural forces. The brewery master provides the raw materials and creates the conditions for transformation. But the actual work of conversion happens through the agency of invisible microorganisms that cannot be controlled directly. The quality of the ingredients determines the potential of this collaboration, setting the upper limits of what can be achieved through fermentation. In the quiet moments when I contemplate a bowl of perfectly aged soy sauce, I can taste the essence of each ingredient still present in the final product. The soybeans contribute their deep, protein-rich umami foundation. The wheat adds layers of subtle sweetness and aromatic complexity. The salt provides structure and balance, preventing any single flavor from overwhelming the others. Together, they create something that transcends the sum of their individual contributions, liquid that carries the concentrated essence of earth and grain and sea, transformed by time into an elixir that enhances every food it touches. The Honjozo Trinity reminds us that complexity need not require complication, that the most profound transformations often arise from the simplest beginnings. Three ingredients, combined with patience and respect for natural processes, create flavors that no amount of artificial manipulation can replicate. In this simplicity lies both the beauty and the challenge of traditional soy sauce production, the recognition that excellence emerges not from addition but from perfection of the essential elements, each playing its sacred role in the slow alchemy of fermentation. I remember the hushed reverence that filled the Koji rooms during those crucial 3 days when simple grains transformed into something alive with enzymatic potential. The air hung thick with controlled humidity, warm enough to encourage growth, but never so hot as to kill the delicate networks spreading invisibly through steamed soybeans and cracked wheat. This was where the magic began, not dramatic or sudden, but gradual and inevitable, like watching winter slowly give way to spring. The preparation began hours before dawn, when the brewery workers would fire up the massive steaming apparatus that would cook the day's batch of soybeans and wheat. Steam billowed from wooden chambers, filling the preparation room with clouds that carried the nutty aroma of proteins unfolding under heat. The soybeans, soaked overnight until they had swelled to nearly twice their original size, would steam for hours until they reached that perfect consistency, soft enough to yield to gentle pressure, yet firm enough to maintain their individual identity throughout the fermentation ahead. The wheat, having been roasted and cracked the previous day, required different treatment. Its time in the steamer was shorter but no less critical, just long enough to gelatinize the starches and make them accessible to the enzymes that would soon be produced. The timing had to be perfect. Overcooked wheat would become mushy and ferment poorly, while undercooked grains would resist enzymatic breakdown and create harsh flavors in the finished soy sauce. I can still feel the texture of properly prepared ingredients beneath my fingertips. The steamed soybeans had a particular give to them, yielding just enough to indicate complete hydration while maintaining the structural integrity that would support fungal growth. The wheat pieces felt lighter, more porous than before steaming. Their surfaces rough and irregular, where the cracking process had exposed starchy interiors to the transformative power of heat and moisture. The cooling process required as much attention as the steaming itself. The hot grains needed to reach exactly the right temperature for inoculation, warm enough to encourage rapid spore germination, but not so hot as to kill the Aspergillus oryzae spores that would soon be dusted across their surfaces. Traditional Koji makers judged this temperature by touch, their experienced hands capable of detecting differences of just a few degrees. Too hot, and the expensive Koji spores would be wasted. Too cool, and germination would be sluggish, allowing harmful bacteria to establish themselves before the beneficial fungus could dominate. The inoculation itself was performed with ceremony befitting its importance. The Kojikin powder, those billions of dormant Aspergillus oryzae spores, would be measured with precision and distributed evenly across the cooling grains. I remember watching master Koji makers at work, their movements economical and practiced as they scattered spore powder like gardeners sowing seeds. The spores themselves were invisible to the naked eye, yet each grain carried the genetic potential to transform pounds of raw material into the enzyme-rich starter that would drive the entire fermentation process. The mixing that followed inoculation was gentle but thorough, ensuring that every grain received its coating of spores without damaging the delicate structure of the steamed ingredients. Wooden paddles moved through the mixture with slow, sweeping motions, folding and turning until the distribution was complete. The inoculated grains were then transferred to the Koji rooms, where they would spend the next 3 days in carefully controlled isolation, protected from contamination while the fungal transformation proceeded. The Koji rooms themselves were marvels of traditional climate control, designed to maintain precise conditions without the benefit of modern heating and cooling systems. Thick walls provided insulation against external temperature fluctuations. Carefully positioned ventilation openings allowed for air circulation without creating drafts that might disturb the developing fungal networks. The floors were often heated by fires below, creating gentle warmth that rose evenly through the room. The trays that held the developing Koji were arranged in precise patterns that maximized air circulation, while allowing easy access for monitoring and stirring. Made of woven bamboo or perforated wood, these trays allowed moisture to escape while supporting the weight of the fermenting grains. The depth of grain in each tray was critical to shallow, and the mixture would dry out. Too deep and anaerobic conditions would develop in the lower layers, encouraging harmful bacteria rather than beneficial fungi. The first 24 hours were perhaps the most crucial in the entire Koji making process. During this period, the Aspergillus oryzae spores would germinate and begin establishing their networks, but they remained vulnerable to competition from other microorganisms. The Koji maker's skill was tested in maintaining exactly the right balance of temperature and humidity conditions that favored rapid fungal germination while discouraging bacterial growth. I remember the subtle signs that indicated successful germination was beginning. The grain mixture would start to give off a faint, sweet aroma, different from the nutty smell of freshly steamed soybeans and wheat. The temperature of the mixture itself would begin to rise slightly, as fungal respiration generated heat. Most tellingly, the individual grains would start to feel slightly sticky when handled, as the first fungal threads began to extend from their surfaces and bind neighboring grains together. The stirring schedule during Koji production was as precisely timed as any ritual. Every 8 to 12 hours, the developing Koji needed to be gently mixed to prevent hot spots from developing and to ensure even access to oxygen throughout the mass. These stirring sessions were opportunities to assess the progress of fermentation, to judge whether conditions needed adjustment, to catch potential problems before they could ruin entire batches. By the second day, the transformation was becoming visible to the naked eye. What had begun as individual grains of soybeans and wheat was now binding together into cohesive masses held together by networks of white fungal threads. The mycelium spread like microscopic root systems, creating biological infrastructure that would soon begin producing the enzymes essential for soy sauce fermentation. The aroma during the second day was intoxicating, a wine-like sweetness that spoke of complex biochemical processes occurring within each grain. The Koji had developed its own internal temperature, often several degrees warmer than the surrounding air. As millions of fungal cells worked to establish their colonies and begin enzyme production, the texture was changing too, becoming softer and more integrated as the fungal networks broke down cellular walls and began the process of molecular transformation. The third day brought the most dramatic, visible changes. The white mycelium thickened considerably, creating dense mats that gave the Koji a fuzzy, almost velvety appearance. In some areas, hints of green began to appear as the fungus prepared for sporulation, the production of a new generation of spores. This color change was a signal that the Koji was reaching maturity, that enzyme production was at its peak and harvest time was approaching. Traditional Koji makers developed an almost mystical ability to judge readiness through their senses. They could detect subtle changes in aroma that indicated peak enzyme activity. They could feel through their fingertips when the fungal networks had reached optimal density. They could see in the color and texture of the mycelium when the moment for harvest had arrived too early, and enzyme levels would be insufficient too late, and the fungus would begin diverting energy towards sporulation rather than enzyme production. The harvesting of mature Koji was timed to capture the moment when enzymatic potential was at its absolute peak. The Koji makers would taste small samples, evaluating the balance of sweet and savory flavors that indicated proper development. Perfectly made, Koji had a distinctive taste, profiledly sweet from the starches being broken down into sugars, with underlying savory notes from proteins beginning their transformation into amino acids. The controlled environment of Koji production represented centuries of accumulated wisdom about managing microbial processes. Every aspect of the 3-day transformation was designed to favor Aspergillus oryzae. While discouraging competitors, the temperature regime encouraged rapid fungal growth while staying below levels that would favor most bacteria. The humidity levels supported fungal development while preventing the waterlogged conditions that might encourage anaerobic fermentation. The stirring schedule provided necessary oxygen while preventing the accumulation of metabolic byproducts that might inhibit growth. I remember learning about the philosophy that guided traditional Koji making, the understanding that human intervention should support natural processes rather than trying to control them completely. The Koji maker created favorable conditions and removed obstacles, but the actual work of transformation was accomplished by the fungus itself. This required a deep trust in biological processes, a willingness to work as a partner with invisible microorganisms rather than trying to dominate them through artificial manipulation. The successful completion of Koji production marked the end of the first major transformation in soy sauce making, but it was only the beginning of a much longer journey. The enzyme-rich Koji would soon be mixed with salt brine to create the moromi mash that would ferment for months or years. But without this crucial first step, without the careful cultivation of Aspergillus oryzae and the production of its enzymatic arsenal, none of the subsequent transformations would be possible. The Koji rooms, emptied of their precious cargo, would be cleaned and prepared for the next batch. The cycle would begin again, steaming, cooling, inoculation, incubation as it had for centuries. Each repetition carrying forward the accumulated wisdom of generations of fermentation masters. In the quiet moments after harvest, when the rooms stood empty except for the lingering aroma of successful transformation, there was time to appreciate the elegant simplicity of the process that had just concluded. 3 days of careful attention had transformed simple grains into biological factories capable of breaking down proteins and starches into the building blocks of flavor. The invisible networks of Aspergillus oryzae had established themselves throughout the Koji, ready to begin the next phase of their work. When introduced to salt brine and the harsh environment of long-term fermentation, the first transformation was complete, but the real magic was just beginning. In those quiet Koji rooms, where humidity and temperature were balanced with the precision of a musical instrument, where timing was measured in hours and success judged by touch and smell, the ancient art of fermentation continued its patient work. Each batch of Koji represented a small miracle of biological transformation, a partnership between human knowledge and microbial capability that had been refined over centuries into something approaching perfection. The first transformation was always the most delicate, the most crucial, the one upon which everything else depended on. In the hands of skilled Koji makers, it proceeded with the inevitability of sunrise, one fungal thread at a time. In those quiet Koji rooms, where humidity and temperature were balanced with the precision of a musical instrument, where timing was measured in hours and success judged by touch and smell, the ancient art of fermentation continued its patient work. Each batch of Koji represented a small miracle of biological transformation, a partnership between human knowledge and microbial capability that had been refined over centuries into something approaching perfection. The first transformation was always the most delicate, the most crucial, the one upon which everything else depended on. In the hands of skilled Koji makers, it proceeded with the inevitability of sunrise, one fungal thread of sunrise, one fungal thread at a time. I remember the moment when the precious Koji met the salt brine for the first time, that gentle splash as enzyme-rich grains slipped beneath the surface of protective liquid beginning their long transformation from solid to sauce. The fermentation tanks stood ready like ancient altars, their wooden walls seasoned by decades of previous batches, their surfaces stained dark with the accumulated essence of countless moromi that had aged within their embrace. This was where the real journey began, where individual ingredients surrendered their separate identities to become something entirely new. The salt brine itself was a carefully crafted environment. More than simple salt water, it was a selective medium designed to encourage certain microorganisms while excluding others. The concentration had to be precise, calculated not just for preservation, but for creating the exact osmotic conditions that would coax flavor compounds from the solid ingredients while maintaining the delicate balance necessary for controlled fermentation. Too little salt and harmful bacteria would flourish. Too much and even beneficial organisms would struggle to establish themselves. I can still recall the ritual of brine preparation, how the brewery workers would dissolve pure salt in clean water, stirring until every crystal disappeared into the clear liquid that would become the aquatic world for fermentation. The salt dissolved gradually, each handful seeming to vanish into the water while contributing its invisible presence to the emerging ecosystem. The final brine had a particular density that experienced brewers could judge by feel, a slight viscosity that spoke of proper salt concentration. The Koji descended into this brine world with surprising grace, the individual grains separating as they encountered the liquid medium. What had been a cohesive mass held together by fungal networks now began to disperse, the salt water penetrating between particles and beginning the process of extraction that would continue for months or years. The Koji brought with it an arsenal of enzymes already at work, ready to begin breaking down proteins and starches in their new aqueous environment. The initial mixture had a porridge-like consistency, thick with suspended solids, yet fluid enough for the gentle stirring that would become a daily ritual. The color was pale, at first creamy beige, from the soybeans and wheat, tinted slightly by the brown of roasted grain. But this initial appearance would change dramatically as fermentation proceeded, as microbial communities established themselves and began the chemical transformations that would eventually produce the dark, complex liquid we recognize as soy sauce. Within hours of combining Koji and brine, the first signs of microbial activity began to appear. The Aspergillus oryzae, having completed its primary role in enzyme production, would gradually fade from dominance as other organisms better adapted to the high-salt environment took over. This succession was not random, but followed predictable patterns that traditional brewers learned to recognize and encourage. The first organisms to establish themselves in significant numbers were typically the lactic acid bacteria, particularly Pediococcus halophilus salt-loving microbes, perfectly adapted to the harsh conditions of high salinity fermentation. These bacteria began immediately to consume the sugars being released from wheat starches by Koji enzymes, producing lactic acid as their primary metabolic waste product. This acid production was crucial for several reasons. It helped preserve the fermentation by creating an increasingly acidic environment, and it contributed the subtle sourness that balances the intense umami and saltiness of mature soy sauce. I remember watching the pH gradually drop over the first weeks of fermentation, as millions of lactic acid bacteria worked their invisible magic. What began as a neutral mixture slowly became acidic, the pH falling from 7 down toward the acidic range that would characterize the final product. This acidification created increasingly hostile conditions for harmful bacteria, while favoring the specialized organisms that could thrive in both high salt and low pH environments. I remember watching the pH gradually drop over the first weeks of fermentation, as millions of lactic acid bacteria worked their invisible magic. What began as a neutral mixture slowly became acidic, the pH falling from 7 down toward the acidic range that would characterize the final product. This acidification created increasingly hostile conditions for harmful bacteria while favoring the specialized organisms that could thrive in both high salt and low pH environments. The aroma during these early weeks was distinctivisty and slightly sour, with underlying notes that hinted at the complexity to come. There was nothing particularly appetizing about the smell of young moromi. It required imagination to envision how this pungent, porridge-like mass would eventually transform into the aromatic liquid that would grace dinner tables around the world. But experienced brewers could detect in these early aromas the promise of proper fermentation, the signs that beneficial microorganisms were establishing themselves successfully. The stirring rituals that began during this phase would continue throughout the long fermentation period. Every few days, workers would use long wooden paddles to mix the moromi gently but thoroughly, ensuring that all portions of the mass had access to oxygen and preventing the development of anaerobic conditions that might favor undesirable organisms. The stirring also helped distribute nutrients and metabolic products evenly throughout the fermentation, promoting uniform development. As weeks passed, the bacterial phase of fermentation gradually gave way to the next stage in microbial succession. The yeasts began to assert themselves, primarily Zygosaccharomyces, Rui and Candida versatilis, specialized organisms capable of surviving and thriving in the extreme conditions of high salt and low pH that the bacteria had created. These yeasts brought their own transformative powers to the fermentation, beginning the production of alcohols and esters that would contribute significantly to the final flavor profile. The yeast fermentation phase was marked by visible changes in the moromi's behavior. Bubbles began to appear more frequently at the surface as the yeasts produced carbon dioxide along with alcohol. The consistency became more fluid as proteins continued to break down and solid particles gradually dissolved into the liquid medium. The color began its slow progression toward the deep brown that would characterize the mature product. I can still sense the complex ecosystem that established itself within each fermentation tank, millions of microorganisms living and dying, consuming and producing, competing and cooperating in an intricate dance of biochemical transformation. The salt brine that had seemed like such a harsh environment actually supported a diverse community of specialized organisms, each contributing its own metabolic products to the developing flavor profile. The interplay between different microbial groups was fascinating to observe. The Koji enzymes continued their work throughout this period, steadily breaking down proteins into amino acids and starches into sugars. The lactic acid bacteria consumed these sugars and produced acids that lowered the pH and created preservative conditions. The yeasts fermented remaining sugars into alcohols while producing aromatic compounds that added complexity. Other microorganisms Various bacteria and yeasts present in smaller numbers contributed their own subtle influences to the overall fermentation. Temperature played a crucial role in managing this microbial succession. Traditional breweries relied on natural temperature fluctuations to guide the fermentation process. Understanding that different organisms were favored at different temperatures, cooler conditions encouraged bacterial growth while slowing yeast activity. Warmer periods accelerated yeast fermentation while potentially stressing some bacterial populations. The seasonal cycle of temperature changes helped ensure that all the necessary microbial transformations occurred in proper sequence. The protective role of salt became increasingly apparent as fermentation proceeded. The high salinity created an environment where only specially adapted organisms could survive, effectively preventing the spoilage bacteria and molds that would quickly ruin unprotected food. This selective pressure meant that virtually all the microorganisms present in the moromi were contributing positively to flavor development, rather than causing decomposition or off flavors. The gradual breakdown of solid materials continued throughout this phase, as enzymatic and microbial action slowly dissolved the original Koji ingredients into the surrounding brine. What had begun as discrete particles of soybeans and wheat was gradually becoming an integrated slurry where the boundaries between solid and liquid became increasingly blurred. This dissolution was essential for eventually producing the clear liquid that would be separated from the solid residue at the end of fermentation. The development of umami compounds accelerated during the moromi phase, as proteins continued their breakdown into amino acids. Glutamic acid, the primary source of umami flavor, accumulated steadily as Koji enzymes cleaved it from soybean proteins. Other amino acids contributed their own flavor, some adding sweetness, others providing subtle bitter or sour undertones that would balance the dominant umami character in the finished sauce. The production of aromatic compounds also intensified as the yeast populations established themselves more firmly. Esters and alcohols created the complex bouquet that would eventually characterize mature soy sauce, while organic acids from bacterial fermentation added their own subtle contributions to the developing aroma profile. The interaction between all these compounds created a fragrance that was unique to soy sauce fermentation, earthy and complex, with hints of wine and cheese and bread all blended into something entirely distinct. The moromi phase represented the heart of soy sauce production, the period where all the preparatory load work of ingredient selection, Koji cultivation, and brine preparation came together in a living, breathing fermentation ecosystem. This was where the real transformation occurred, where simple ingredients became complex flavors through the patient work of invisible microorganisms. The process could not be hurried or forced. It proceeded according to its own biological rhythms, guided by the seasonal cycles and the accumulated wisdom of generations of brewers who had learned to work with, rather than against, the natural tendencies of fermentation. In the quiet fermentation halls, where dozens of tanks held their precious cargo, the birth of moromi marked the beginning of a journey that would continue for months or years. Each tank contained its own unique ecosystem, its own community of microorganisms working together to create something that no single organism could produce alone. The salt brine that had seemed so hostile at first had become a nurturing environment where beneficial microbes could thrive and multiply, transforming simple ingredients into liquid complexity, one microscopic reaction at a time. The workers who tended these fermentation tanks understood that they were not so much controlling the process as shepherding it, creating conditions where natural transformations could proceed successfully. Their daily stirring rituals, their careful monitoring of temperature and pH, their patient observation of color and aroma changes, all of this represented a partnership between human knowledge and microbial capability that had been refined over centuries into something approaching perfection. The birth of moromi was always a moment of both accomplishment and anticipation, marking the successful beginning of a transformation that would continue long into the future. In the quiet fermentation halls where dozens of tanks held their precious cargo, the birth of moromi marked the beginning of a journey that would continue for months or years. Each tank contained its own unique ecosystem, its own community of microorganisms working together to create something that no single organism could produce alone. The salt brine that had seemed so hostile at first had become a nurturing environment where beneficial microbes could thrive and multiply, transforming simple ingredients into liquid complexity, one microscopic reaction at a time. The workers who tended these fermentation tanks understood that they were not so much controlling the process as shepherding it, creating conditions where natural transformations could proceed successfully. Their daily stirring rituals, their careful monitoring of temperature and pH, their patient observation of color and aroma changes, all of this represented a partnership between human knowledge, of this represented a protringship between knowledge and microbial capability that had been refined entering unkushin with support by pro which and The birth of moromi was always a moment of both accomplishment and anticipation, marking the successful beginning of a transformation that would continue long into the future. I remember the peculiar quality of time in the fermentation halls during those long months of aging how days blended into weeks, weeks into seasons, seasons into years, while the moromi underwent its slow metamorphosis from thick, porridge-like mash to the complex liquid that would eventually grace tables around the world. There was something almost meditative about this extended waiting, this patient partnership with processes that could not be hurried, only guided and protected as they followed their ancient rhythms. The daily stirring became a ritual as regular as sunrise, performed with wooden paddles that had been seasoned by decades of use. These implements, darkened by contact with countless batches of aging moromi, moved through the thick mass with practiced motions that introduced precious oxygen while preventing stagnation. The workers who performed this daily ceremony understood that they were not merely mixing, but breathing life into the fermentation, providing the aerobic conditions that specialized yeasts and bacteria required for their transformative work. I can still feel the resistance of the moromi against the paddle, that distinctive thickness that spoke of proteins breaking down and reforming, of cellular structures dissolving into the surrounding liquid, of complex biochemical processes that were gradually converting solid ingredients into liquid essence. The texture changed subtly over months, becoming more fluid as enzymatic action continued its patient work of dissolution. What had begun as separate grains of koji suspended in brine was slowly becoming an integrated mass where the boundaries between ingredients disappeared entirely. The color transformation during aging was perhaps the most visually striking aspect of the long fermentation. The pale, cream-colored mixture of early moromi gradually darkened, taking on deeper and richer tones as mellowed reactions proceeded between proteins and sugars. These same chemical processes that brown bread in the oven or caramelize onions in a pan worked there. Magic over months rather than minutes, creating the complex flavor compounds and deep brown color that would characterize mature soy sauce. Seasonal temperature fluctuations played a crucial role in guiding the fermentation through its various phases. Traditional breweries relied on these natural cycles rather than fighting them, understanding that different temperatures favored different aspects of the transformation process. Summer's heat accelerated yeast activity and enzyme action, pushing fermentation forward at an increased pace. Winter's cold slowed microbial processes, allowing time for flavor development and maturation that could not occur during periods of rapid change. The moromi breathed with the seasons, its metabolism quickening in warm weather and resting during cold spells. I remember the way fermentation activity would intensify during the first warm days of spring, bubbles appearing more frequently at the surface as dormant yeasts awakened and resumed their work. The aroma would change too, becoming more active and alive, carrying hints of alcohol and organic acids that spoke of renewed microbial activity. Summer brought its own challenges and opportunities to the aging process. The higher temperatures accelerated all biochemical processes, potentially compressing months of slow development into weeks of intense activity. Traditional brewers learned to manage this acceleration, using increased stirring frequency and careful monitoring to prevent overheating that might damage delicate flavor compounds or favor undesirable microorganisms. The summer months tested both the skill of the brewers and the stability of their fermentation ecosystems. The autumn cooling period marked a transition in the character of aging moromi. As temperatures dropped, the frenzied activity of summer gave way to slower, more methodical processes. Proteins continued their breakdown into amino acids, but at a pace that allowed for the development of complex flavor interactions. The harsh edges that characterized younger fermentations began to smooth and integrate as different flavor compounds found their balance and harmony. Winter imposed its own rhythm on the fermentation halls, slowing everything to a pace that seemed almost suspended in time. The moromi in the great wooden vats moved sluggishly when stirred, their thick consistency holding the cold like a memory. But even in this apparent dormancy, important processes continued. Enzymes worked with quiet persistence, breaking down remaining proteins and starches. Beneficial bacteria maintained their populations, ready to resume more active growth when warmer weather returned. The annual cycle of temperature changes ensured that the moromi experienced the full range of conditions necessary for complete flavor development. Each season contributed its own characteristics to the aging process. Summer's rapid transformation, autumn's integration and smoothing, winter's deep maturation, spring's reawakening. A soy sauce that aged through multiple complete cycles developed complexity that could not be achieved through artificial temperature control or accelerated processing. I remember learning to read the subtle signs that indicated proper progression through the aging phases. The aroma evolved continuously harsh and yeasty in the early months, gradually developing the wine-like complexity that characterized mature fermentation. The color deepened predictably, following patterns that experienced brewers could track as reliably as following a calendar. The texture became increasingly fluid as solid components dissolved into the liquid medium. The pH continued its gradual decline throughout the aging period as beneficial bacteria produced additional organic acids. This ongoing acidification served multiple purposes, helped preserve the fermentation against harmful microorganisms. It contributed to the balanced flavor profile of the finished sauce, and it created increasingly selective conditions that favored the specialized organisms, responsible for the most desirable flavor compounds. Alcohol production peaked during the warmer months when yeast activity was most intense, then gradually declined as the yeasts consumed available sugars and entered more dormant phases. The alcohol content rarely exceeded a few percent, but these small amounts of ethanol played important roles in extracting flavor, compounds from solid components, and in creating the aromatic esters that contributed to soy sauce's complex bouquet. The breakdown of proteins accelerated during warmer periods, but continued throughout the entire aging cycle. Amino acids accumulated steadily, with glutamic acid, the primary source of umami flavor-reaching concentrations that would make mature soy sauce one of the richest natural sources of this savory taste. Other amino acids contributed their own flavor notes, creating the complex profile that distinguished properly aged soy sauce from younger or artificially accelerated versions. The development of aromatic compounds followed its own timeline, with different esters and aldehydes appearing at various stages of the aging process. Some appeared early and then faded, serving as intermediates in longer chemical pathways. Others accumulated gradually, building the complex bouquet that would characterize the finished sauce. The interaction between all these volatile compounds created an aroma profile that could only be achieved through extended natural aging. Traditional brewers developed an almost mystical ability to judge the progress of aging moromi through their senses. They could detect in the aroma subtle notes that indicated proper development or warned of potential problems. They could feel in the texture changes that revealed the extent of protein breakdown and solid dissolution. They could see in the color progression whether the Maillard reactions were proceeding at the optimal rate for flavor development. The patience required for proper aging tested both the economic constraints and the philosophical commitment of traditional producers. Moromi that would not be ready for sale for 2 or 3 years represented a significant investment of both space and ingredients. The temptation to accelerate the process through artificial heating or other shortcuts was always present, but the best producers understood that true quality could only be achieved through patient cooperation with natural rhythms. The seasonal stirring schedule adapted to the changing needs of aging moromi. Summer's frequent stirring prevented overheating and ensured adequate oxygen distribution during periods of intense microbial activity. Winter's reduced stirring frequency acknowledged the slower metabolism of cold weather fermentation while still maintaining the gentle movement necessary to prevent stagnation. Spring and autumn required their own adjustments as the fermentation transitioned between active and dormant phases. The fermentation halls themselves seemed to participate in the seasonal rhythms, their wooden walls expanding and contracting with temperature and humidity changes. their aged surfaces breathing with the moromi they contained. The buildings developed their own microclimate, moderated by thermal mass and structural design to buffer the moromi against extreme temperature swings, while still allowing the beneficial effects of seasonal cycling. I remember the particular quality of silence in the fermentation halls during winter months, when the reduced microbial activity created an almost suspended atmosphere. The moromi rested in its vats like sleeping giants, their slow breathing barely perceptible except to the most experienced observers. Yet beneath this apparent dormancy, crucial processes continued, flavors integrating, harsh compounds mellowing, complexity developing through pathways that required both time and patience. The long aging period served purposes beyond mere flavor development. It allowed time for the gradual clarification that would make the final pressing and filtration more effective. Solid particles slowly settled or dissolved, reducing the cloudiness that characterized young moromi. Proteins aggregated and precipitated, removing compounds that might cause haziness in the finished sauce. The extended aging essentially began the clarification process that would be completed during final processing. The economic reality of extended aging meant that traditional soy sauce production required significant capital investment and long-term thinking. Breweries needed enough capacity to maintain multiple batches at various stages of aging, ensuring continuous production despite the long maturation periods. This requirement favored family operations that could take a generational view of their business, planning for markets and returns that might not materialize for years. The philosophy that guided traditional aging emphasized cooperation with natural processes rather than attempts to control or accelerate them. Brewers saw themselves as partners in the transformation, providing optimal conditions and protection while allowing the moromi to develop according to its own biological rhythms. This approach required both scientific understanding and intuitive sensitivity knowledge of the processes involved combined, with the patience to let them proceed at their natural pace. In those quiet fermentation halls where time moved to rhythms older than human memory, the moromi continued its patient transformation through countless seasons of heat and cold, rain and drought, light and darkness. Each batch carried within itself the accumulated wisdom of generations of brewers who had learned to read the subtle signs of proper development, to provide guidance without interference, to trust in processes that could not be rushed or forced, but only encouraged and protected. The long wait was not empty time, but full time every day, bringing small changes, every season contributing its own gifts to the slow alchemy that would eventually produce liquid perfection. I remember the moment of truth when years of patient fermentation finally yielded their treasure, that first precious drop of Koji raw soy sauce, emerging from the cloth-lined pressing containers like liquid amber distilled from time itself. After months or years of stirring and waiting, of watching colors deepen and aromas evolve, the moromi had reached the point where its transformation from solid mash to liquid essence could finally be completed. The pressing process was both mechanical and mystical, a final act of extraction that would separate the ethereal from the earthly, the source from the solids that had given it birth. The preparation for pressing began with careful evaluation of the aged moromi. Master brewers would taste samples, testing for the complex balance of flavors that indicated readiness for separation. The mash should have developed its full complement of amino acids with glutamic acid concentrations that would deliver rich umami character. The proteins should have broken down sufficiently to create smooth, integrated flavors without harsh or unfinished notes. The color should have reached the deep brown that spoke of proper Maillard development and enzymatic browning. The pressing apparatus itself was a marvel of traditional engineering, massive wooden structures that could apply tons of pressure gradually and evenly across cloth-wrapped bundles of fermented mash. The cloths were specially woven, their weave fine enough to retain solid particles while allowing liquid to flow freely. Layer upon layer of these cloth bundles would be stacked in the pressing chambers, with wooden boards distributing weight evenly across each level. I can still picture the ritual of loading the press, how workers would carefully ladle the thick, dark moromi into cloth squares, folding the edges to create neat packages that would stack cleanly in the pressing chamber. Each bundle contained gallons of fermented mash, compressed into forms that would yield their liquid treasure under pressure. The loading process required precision to much mash in each bundle, and the cloth might tear under pressure. Too little, and the pressing would be inefficient. The first gentle pressure would be applied slowly, allowing the moromi to settle and compress without forcing liquid through the cloths too rapidly. This initial pressing was as much about preparation as extraction, consolidating the solid components and beginning the separation process that would intensify over the following days. The first drops of liquid to emerge were often cloudy, carrying suspended particles that would settle out as pressing continued. The color of these first drops was darker than the final product would be, concentrated with dissolved compounds that had been extracted under the initial pressure. This early kayage had an intensity of flavor that was almost overwhelming, pure essence of fermentation, undiluted by the clearer liquid that would follow. Traditional brewers would taste these first drops carefully, reading in them the character of the entire batch and adjusting their pressing techniques accordingly. As pressure gradually increased over hours and days, the character of the emerging liquid evolved. The initial dark, cloudy flow gave way to clearer, amber streams that carried the more subtle flavors that had developed during fermentation. The extraction process was revealing the different layers of complexity that had built up over the long aging period. First, the concentrated essences, then the more delicate aromatics, finally the clean, clear liquid that would form the bulk of the final product. The patience required during pressing matched that needed throughout the fermentation process. Rapid pressing might extract more liquid quickly, but it would also force through solid particles and harsh compounds that would cloud the sauce and create off flavors. Gentle, extended pressing allowed time for natural settling and clarification, producing cleaner liquid with better flavor balance. The best producers would press for days, extracting every drop of precious liquid while maintaining the quality that justified the extended process. I remember the sound of liquid dripping steadily from the press cloths, not a rapid flow but a patient rhythm that spoke of thorough extraction proceeding at its own pace. Each drop carried within itself the concentrated essence of months or years of transformation, the liquid embodiment of all the careful work that had preceded this moment. The collection vessels beneath the press would slowly fill with amber liquid that seemed to glow with its own internal light. The temperature control during pressing was crucial for maintaining quality. The mechanical pressure generated heat that could damage delicate flavor compounds or encourage undesirable chemical reactions. Traditional pressing was designed to proceed slowly enough that heat buildup was minimized, preserving the subtle aromatics and balanced flavors that distinguished high-quality soy sauce. The solid residue that remained after pressing the sakekasu, or pressing cake, was not waste but a valuable byproduct with its own uses. This compressed mass of fermented soybeans and wheat retained significant nutritional value and flavor, finding applications in animal feed, fertilizer, and even human food products. The efficient extraction of liquid sauce, while preserving the utility of solid residues, represented the kind of complete utilization that characterized traditional fermentation practices. The Koji that emerged from pressing was still not ready for bottling or sale. This raw soy sauce contained suspended particles that would settle over time, and its flavor profile, while complete, lacked the final polish that would characterize the finished product. The next crucial step was pasteurization, not merely for food safety, although that was important, but for the final flavor development that only heat treatment could provide. The pasteurization process was itself an art, requiring careful control of temperature and timing to achieve the desired effects without damaging the delicate balance of flavors that had developed during fermentation. Too little heat and harmful microorganisms might survive, while desired Maillard reactions remained incomplete. Too much heat and the subtle aromatics would be driven off, leaving the sauce flat and lifeless. Traditional pasteurization was accomplished in large copper or stainless steel vessels, where the raw Koji was heated gradually while being stirred to ensure even temperature distribution. The target temperature was hot enough to kill potentially harmful bacteria and yeasts, while encouraging the final Maillard reactions that would perfect both color and flavor. Steam would rise from the heating vessels, carrying with it some of the volatile compounds that had been present in the raw sauce, while concentrating others through evaporation. I can still smell the distinctive aroma that filled the pasteurization rooms during this processor combination of heated proteins, caramelizing sugars, and the complex bouquet of fermented soybeans on wheat. The heat treatment intensified certain flavors, while mellowing others, creating the final balance that would characterize the finished sauce. The color deepened further during pasteurization, reaching the rich brown that consumers expected from high-quality soy sauce. The chemistry of pasteurization involved more than simple heating. The elevated temperatures accelerated Maillard reactions between amino acids and sugars, creating additional flavor compounds and aromatic molecules that had not been present in the raw sauce. Proteins that had survived fermentation were further modified by heat, some coagulating and precipitating out of solution, others breaking down into smaller, more flavorful fragments. The timing of pasteurization was critical for achieving optimal results. Extended heating would drive off volatile aromatics and create harsh, cooked flavors that masked the subtle complexities developed during fermentation. Insufficient heating would leave the sauce microbiologically unstable, while failing to complete the final flavor development. Master brewers learned to judge the proper endpoint by aroma, color, and taste, knowing exactly when to halt the heating process. The cooling that followed pasteurization required almost as much care as the heating itself. Rapid cooling could create thermal shock that affected both flavor and clarity. Gradual cooling allowed time for the final settling of proteins and other particles that had been mobilized by heat treatment. The properly pasteurized sauce would cool to a clear, stable liquid with a balanced flavor profile that integrated all the complexity developed during fermentation with the final polish provided by heat treatment. Filtration followed pasteurization, removing any remaining suspended particles and creating the crystal clear appearance that distinguished premium soy sauce from cloudy, unfinished alternatives. Traditional filtration used layers of cloth and natural materials, relying on gravity and time rather than mechanical force to achieve clarification. Modern operations might employ more sophisticated filtration systems, but the goal remained the same: perfect clarity, without removing the flavorful compounds that gave the sauce its character. The final product that emerged from this extensive processing bore little visual resemblance to the thick, porridge-like moromi from which it had been extracted. Clear amber liquid had replaced chunky, solid mash. Smooth, integrated flavors had emerged from the harsh, yeasty character of young fermentation. Complex aromatics had developed from simple ingredient odors. The transformation was complete. Liquid gold had been distilled from the patient alchemy of time and fermentation. Quality control during the final processing stages required constant vigilance and expert judgment. Each batch was unique, requiring slight adjustments to pressing pressure, pasteurization, temperature, or filtration techniques based on its individual characteristics. The master brewers who oversaw these final steps carried in their sensory memory the standards for color, clarity, aroma, and flavor that defined their brewery's reputation. The moment when the first bottles were filled with finished sauce marked both an ending and a beginning. Years of patient work had culminated in this liquid essence, ready to carry the concentrated flavors of fermentation to tables around the world. But it was also the beginning of the sauce's final journey, from brewery to distributor to retailer to consumer, where it would fulfill its ultimate purpose of enhancing and transforming the foods with which it would be combined. In those final moments of the pressing process, when the last drops of precious liquid were being extracted from the spent mash, there was time to appreciate the remarkable transformation that had occurred. Simple ingredients had become complex flavors through the patient work of invisible microorganisms, guided by human knowledge and protected by traditional techniques refined over centuries. The final press marked not just the physical separation of liquid from solid, but the completion of an ancient compact between human intention and natural processor partnership that continued to produce liquid gold from the patient marriage of soybeans, wheat, salt, and thyme. I remember the moment when I first understood that soy sauce was not a single thing, but an entire family of related liquids, each with its own character, its own purpose, its own place in the complex hierarchy of Japanese cuisine. Standing before a collection of bottles that ranged from pale gold to nearly black, from thin and light to thick and viscous, I began to appreciate the subtle artistry that had evolved over centuries to create this spectrum of flavors and applications. What I had once considered a simple condiment revealed itself as a diverse palette of liquid seasonings, each crafted for specific culinary purposes. Essence of Shōyu stood at the center of this family, the standard bearer, the everyday sauce that most people simply called soy sauce without qualification. Its balanced profile made it the versatile workhorse of Japanese kitchens, equally at home in marinades and dipping sauces, in cooking and at the table. The deep brown color spoke of proper fermentation and aging, while the balanced flavor integrated umami richness with subtle sweetness and just enough acidity to brighten rather than overwhelm other ingredients. I can still taste that first proper koikuchi, how it delivered its flavor in waves, the initial hit of salt and umami, followed by the deeper complexity of fermented proteins and the gentle sweetness from wheat-derived sugars. The finish was clean and long, encouraging rather than masking the natural flavors of the foods it accompanied. This was the standard by which all other soy sauces would be measured, the baseline that had emerged from centuries of refinement and regional preference. The production of koikuchi followed the traditional process, most closely equal proportions of soybeans and wheat, standard salt concentrations, and aging periods that typically ranged from 6 months to several years. The Koji cultivation emphasized balanced enzyme production, creating conditions that would break down both proteins and starches at rates that produced the integrated flavor profile koikuchi was known for. Regional variations existed, of course, but the basic parameters had been established through generations of consumer preference and brewer innovation. Essence of Shōyu presented a fascinating paradox, lighter in color than koikuchi, but actually saltier in flavor. This pale golden liquid achieved its distinctive appearance, not through shorter fermentation, but through different production techniques that limited color development while maintaining full flavor complexity. The lighter color made it precious for dishes where visual appearance was crucial, where the dark color of regular soy sauce would muddy the clean presentation that Japanese cuisine prized. The creation of yusukuchi required sophisticated understanding of the fermentation chemistry that produced color. Brewers learned to modify their processes to limit Maillard reactions while preserving the enzymatic breakdown that created flavor compounds. Sometimes this involved different Koji cultivation techniques, sometimes adjusted salt concentrations or shortened aging periods. The result was a sauce that looked delicate but packed intense flavor, requiring careful use to avoid overwhelming delicate ingredients. I remember learning to appreciate usakuchi's role in the seasonal cuisine of Kyoto, where its light color allowed the natural colors of vegetables and seafood to shine through without sacrificing the depth that soy sauce provided. A few drops could transform a clear soup or highlight the subtle sweetness of spring vegetables without creating the visual heaviness that regular soy sauce might impose. The higher salt content meant that less was needed, creating clean, precise flavors that matched the aesthetic of refined Japanese cooking. Tamari represented the oldest tradition in this family of sauces, the direct descendant of the accidental discovery in Kokushin's temple nearly 8 centuries earlier. Made primarily or exclusively from soybeans with little or no wheat, tamari developed different characteristics that set it apart from its wheat-containing cousins. The absence of wheat starches meant less sugar production during fermentation, resulting in a sauce that was more purely protein-derived, with intensely concentrated umami flavors and a thicker, more viscous texture. The color of tamari was typically darker and richer than koikuchi, approaching the deep burgundy that spoke of pure soybean fermentation. The flavor was more intense and concentrated, with a richness that came from higher protein levels and extended aging. Modern tamari production often emphasized these traditional characteristics, creating sauces that appealed to consumers seeking more authentic or intense flavors, as well as those requiring gluten-free alternatives to wheat-containing soy sauces. I can still recall the first time I tasted pure tamari, the way it coated the palate with concentrated umami. The almost meaty richness that came from soybeans transformed entirely by fermentation without the moderating influence of wheat-derived sugars. It was soy sauce distilled to its essence, uncompromising in its intensity and surprisingly complex in its layered flavors. Used sparingly, it could transform simple dishes into something profound. Shiro Shōyu occupied the opposite end of the spectrum from tamari, pale, delicate, and almost ethereal in appearance. This white soy sauce was actually a pale amber color achieved through production methods that emphasized wheat over soybeans and limited fermentation time to prevent color development. The result was a sauce with subtle flavor and minimal color impact, prized for dishes where even yuzukuchi might be too visually intrusive. The production of Shiro required careful balancing of ingredients and timing. Higher proportions of wheat provided the starches that would ferment into the subtle sweetness that characterized this style, while reduced soybean content limited protein fermentation that would create both color and intense umami flavors. The fermentation was carefully controlled to develop flavor complexity while preventing the enzymatic browning that would darken the liquid. Shiro Shōyu found its perfect expression in the delicate cuisine of tea ceremony and formal kaiseki dining, where its whisper of flavor could enhance without announcing its presence. I remember watching master chefs use it to season clear broths and pale vegetables, adding depth that was felt more than tasted, creating layers of subtle complexity that supported rather than competed with primary ingredients. The regional variations within each style reflected local preferences and historical accidents that had been preserved and refined over generations. Kyushu producers might favor slightly sweeter profiles, while northern brewers developed sauces with more pronounced fermentation character. These differences were often subtle adjustments in Koji cultivation, variations in aging time, modifications to salt content, but they created distinct regional identities that loyal consumers could detect and appreciate. Chinese soy sauce traditions had evolved along parallel but distinct paths, creating their own categories of light and dark sauces with different characteristics from their Japanese cousins. Chinese light soy sauce was typically saltier and thinner than Japanese varieties, designed for different cooking techniques and flavor preferences. Dark soy sauce was often sweetened with molasses or sugar, creating thick, almost syrupy textures and sweet-savory flavor profiles that worked well with the bold flavors of Chinese cuisine. I remember exploring Chinese soy sauce varieties and discovering how different fermentation traditions had created products that shared common ancestry but served different culinary purposes. The light sauces were designed for seasoning and flavor enhancement, while dark varieties functioned more like liquid seasonings that added both color and sweetness to dishes. The thickness and sweetness of dark Chinese soy sauce made it particularly effective for braising and stewing, where it could coat ingredients and create rich, glossy finishes. The production techniques for Chinese varieties often differed significantly from Japanese methods. Some employed different Koji strains or fermentation temperatures. Others used varying ratios of soybeans to wheat or different aging periods. These technical differences reflected cultural preferences and cooking styles that had diverged over centuries, creating related but distinct traditions within the broader family of fermented soy sauces. Southeast Asian fish sauce traditions represented another branch of the fermentation family tree, using fish instead of soybeans as the primary protein source. but employing similar principles of salt-controlled fermentation and aging. Vietnamese Ngoc Mam, Thai Nam Plot, and Filipino Patis all demonstrated how the basic concept of protein fermentation could be adapted to different ingredients and cultural preferences while maintaining the essential character of liquid umami seasoning. The appreciation of soy sauce varieties required developing sensitivity to subtle differences in color, aroma, flavor, and texture. What might seem like minor variations to untrained palates revealed themselves as significant distinctions when experienced in the context of specific dishes and cooking techniques. Each variety had evolved to fill particular niches in culinary traditions, creating tools that matched specific needs rather than attempting universal application. I learned to taste soy sauces systematically, evaluating them on multiple dimensions: the initial impact on the palate, the development of flavors over time, the balance between salt, umami, sweetness, and acidity, the way they enhanced or competed with other ingredients. Professional tastings revealed layers of complexity that casual use might never uncover, demonstrating how centuries of refinement had created products of remarkable sophistication. The family recipes and trade secrets that distinguished one producer from another often involved seemingly minor adjustments to standard processes. A particular strain of Koji, a specific aging temperature, a unique filtration technique, these small variations could create signature characteristics that loyal customers recognized and preferred. The cumulative effect of many subtle choices resulted in products that might seem similar but possessed distinct personalities that reflected their makers' skills and philosophies. Modern industrial production had created standardized versions of traditional varieties, making consistent quality available on a global scale, but sometimes at the cost of the individual character that had distinguished traditional producers. The challenge for contemporary brewers was maintaining efficiency and consistency while preserving the nuanced differences that made each variety valuable for specific applications. The survival and celebration of traditional varieties reflected deeper values about preserving cultural heritage and maintaining connection to historical foodways. Each style of soy sauce carried within itself centuries of accumulated knowledge about fermentation, flavor development, and culinary application. The continued production of tamari, yusukuchi, shiro, and regional specialties represented a commitment to diversity and tradition that enriched the global food landscape. In the quiet moments when I contemplated this spectrum of related but distinct sources, I appreciated the human creativity that had taken a basic fermentation process and evolved it into such diversity of expression. From the robust intensity of aged tamari to the ethereal delicacy of shiro shōyu, from the balanced versatility of koikuchi to the visual lightness of yusukuchi, each variety represented solutions to different culinary challenges, tools crafted over generations to serve specific purposes while maintaining connection to common ancestral techniques. The world of soy sauce varieties reminded me that tradition was not static preservation but living evolution, constantly adapting to new needs and preferences, while maintaining essential characteristics that connected present practice to historical foundation. Each bottle contained not just fermented soybeans and wheat, but centuries of accumulated wisdom about how simple ingredients could be transformed through patience and skill into liquid complexity that enhanced the fundamental pleasure of eating. I remember the creaking of wooden ships as they rocked gently in Nagasaki harbor, their holds heavy with ceramic vessels containing dark liquid that would soon cross oceans to reach palates that had never experienced its complex embrace. The year was 1600 and something, when Dutch East India Company traders first encountered this mysterious fermented sauce in Japanese ports and recognized its potential to transform European cuisine. Those early bottles, secured in straw wrapping and sealed with wax against the salt spray of long voyages, carried within them centuries of accumulated wisdom about fermentation and flavor, knowledge that would soon spread far beyond the mountain valleys where it had been born. The Dutch merchants who first imported soy sauce to Europe understood trade better than cuisine, but they recognized quality when they tasted it. This dark liquid possessed keeping qualities that made it valuable for long sea voyages, flavor intensity that meant a little went a long way, and a capacity to enhance other foods that suggested broad commercial potential. The early importers could not have imagined how completely this Asian condiment would eventually integrate itself into global cuisine, but they sensed opportunity in every bottle they loaded into their cargo holds. The journey from Japan to European ports took months, with stops at trading posts across Southeast Asia, where Dutch factors would add more exotic goods to their collections. The soy sauce traveled in company with spices and silks, porcelain and tea, part of the great exchange of Asian luxuries for European silver that defined early global commerce. During those long voyages, the sauce continued its slow maturation in the dim holds of sailing ships, developing flavors and complexity through processes that continued even in transit. I can picture the first European kitchens where curious cooks experimented with this strange new seasoning, trying to understand its properties and applications. The initial attempts were probably clumsy, too much sauce, overwhelming delicate European flavors, or too little, failing to demonstrate its transformative power. But gradually, through trial and error, European cooks began to discover how this Asian condiment could enhance their traditional dishes while inspiring entirely new culinary directions. The integration of soy sauce into Worcestershire sauce represents one of the most successful early adaptations of Asian fermentation techniques to European tastes. In the 1830s, when John Wheely Lee and William Henry Perrins were developing their famous condiment in Worcester, England, they included soy sauce as a key ingredient alongside anchovies, tamarind, molasses, and various spices. The result was a complex liquid seasoning that carried the umami depth of Asian fermentation while appealing to British palates accustomed to bold, savory flavors. The creation of Worcestershire sauce demonstrated how traditional fermentation wisdom could cross cultural boundaries and adapt to new ingredients and preferences. The soy sauce provided the fermented depth that gave the condiment its distinctive character, while other ingredients modified and complemented those base flavors to create something that was neither purely Asian nor purely European, but genuinely international in its appeal. American encounters with soy sauce began with the China trade of the early 19th century, when merchant ships brought back not just goods, but also culinary experiences from their Pacific voyages. Chinese restaurants in California's gold rush towns introduced American palates to Asian flavors, including the various soy sauces that were essential to authentic Chinese cooking. These early exposures planted seeds of familiarity that would later support broader acceptance and adoption. The post-World War II era brought unprecedented changes to global food distribution and cultural exchange. American soldiers, returning from Pacific theaters, carried with them acquired tastes for Asian foods, including soy sauce. Simultaneously, improved transportation and refrigeration made it possible to distribute perishable and specialty foods across vast distances, opening new markets for traditional Asian products. Kikkoman's decision to build production facilities in the United States represented a pivotal moment in soy sauce's global expansion. Rather than simply exporting finished products from Japan, the company chose to recreate traditional fermentation processes in American facilities, adapting their ancient techniques to new climates and regulatory environments, while maintaining the essential character that defined their products. I remember visiting the Kikkoman facility in Wisconsin, where traditional wooden fermentation vessels had been replaced by massive steel tanks, but the fundamental processes remained unchanged. Soybeans and wheat were still carefully prepared and inoculated with Koji. Salt brine still protected the developing moromi during months of patient fermentation. The seasonal rhythms that had guided Japanese production for centuries were replicated in American facilities through careful climate control and process management. The adaptation of traditional brewing techniques to industrial scale required solving problems that had never existed in small-scale production. Quality control systems needed to ensure consistency across batches measured in thousands of gallons rather than dozens. Fermentation schedules had to be coordinated to maintain continuous production while respecting the biological rhythms that could not be artificially accelerated. Distribution networks had to be developed to carry the finished products to markets scattered across vast continental distances. The discovery of umami as a distinct taste category helped explain soy sauce's universal appeal and supported its integration into cuisines that had no historical connection to Asian fermentation traditions. When Kikune Ikeda identified glutamate as the source of this fifth taste in 1908, he provided scientific validation for what cooks had known intuitively for centuries. The scientific understanding of umami made it easier to market soy sauce to Western consumers who might have been suspicious of unfamiliar fermented foods, rather than asking people to accept something strange and foreign. Producers could explain how soy sauce provided a natural source of flavors that enhanced familiar foods. The umami content of aged soy sauce rivaled that of aged cheeses and cured meats, placing it in a category of premium ingredients that sophisticated cooks could appreciate and understand. Modern global production of soy sauce encompasses both traditional and industrial approaches, creating products that serve different market segments and culinary applications. Artisanal producers in Japan continue to operate much as their ancestors did, using wooden fermentation vessels and natural temperature cycling to create premium products for discerning consumers. Industrial operations produce consistent, affordable versions that make soy sauce accessible to home cooks and restaurants worldwide. The tension between traditional and modern production methods reflects broader questions about authenticity, quality, and cultural preservation in an increasingly globalized food system. Traditional producers argue that their time-intensive methods create superior flavor and maintain cultural connections that industrial processes cannot replicate. Industrial producers contend that their methods make high-quality products accessible to more people, while maintaining essential characteristics through scientific process control. I remember tasting soy sauces from different global production facilities and being surprised by the subtle variations that reflected local conditions and preferences. Water sources affected mineral content and flavor development. Climate differences influenced fermentation, timing, and character. Even identical production processes yielded products with distinct personalities when implemented in different locations by different teams of brewers. The globalization of soy sauce has created new hybrid cuisines that combine Asian fermentation techniques with local ingredients and preferences. Mexican restaurants use soy sauce in marinades for carne asada. Italian chefs incorporate it into reductions and glazes. American barbecue pitmasters add it to dry rubs and sauces. These applications would have been unimaginable to the Zen priests who first discovered tamari, but they represent natural evolution of fermentation wisdom as it encounters new culinary contexts. The rise of health consciousness and dietary restrictions has created new opportunities for traditional soy sauce varieties. Tamari's naturally gluten-free character appeals to consumers avoiding wheat, while its intense flavor satisfies those seeking umami-rich foods. Low-sodium versions meet the needs of health-conscious consumers without sacrificing the flavor enhancement that makes soy sauce valuable. The artisanal revival in global food culture has renewed interest in traditional production methods and premium quality soy sauces. Craft brewers experiment with heritage soybean varieties and extended aging periods. Specialty food stores stock multiple soy sauce varieties from different regions and producers. Cooking shows and food writers educate consumers about the differences between mass-produced and artisanal products. The last traditional wooden fermentation vessels in Japan represent both historical continuity and economic challenge. These massive cedar vats, some over a century-old, harbor unique microbial communities that cannot be replicated in steel tanks or relocated to new facilities. The few remaining producers who use wooden vessels charge premium prices for products that carry within them irreplaceable biological heritage. I have stood beside these ancient wooden vats, breathing air thick with the accumulated aromas of decades of fermentation, understanding that I was witnessing the end of an era. The craftsmen who tend these vessels are aging, and few young people show interest in learning techniques that require years of apprenticeship to master. The economic pressures of global competition make it difficult to justify the time and expense required to maintain traditional wooden fermentation systems. Yet, the global appreciation for soy sauce continues to grow, driven by increasing sophistication among consumers who seek authentic flavors and cultural experiences through food. Premium restaurants feature multiple soy sauce varieties on their menus. Home cooks experiment with different styles for different applications. The internet enables direct sales from small producers to consumers worldwide, creating new markets for traditional products. The story of soy sauce's global journey reflects broader patterns of cultural exchange and adaptation that define our modern world. Ideas and techniques that developed in isolation over centuries now spread across continents in decades or years. Traditional wisdom encounters industrial efficiency, creating hybrid approaches that serve new markets while maintaining essential characteristics. The future of soy sauce production will likely involve continued diversification, large-scale industrial operations serving mass markets, artisanal producers creating premium products for sophisticated consumers and innovative approaches that combine traditional wisdom with modern technology. The fundamental processes of fermentation remain unchanged, but their application continues to evolve as they encounter new challenges and opportunities. In the quiet moments when I contemplate a simple bottle of soy sauce, I can taste the entire history. It contains the patient work of invisible microorganisms, the accumulated wisdom of generations of fermentation masters, the courage of traders who carried it across dangerous seas, the creativity of cooks who adapted it to new cuisines. Each drop connects present pleasure to ancient knowledge, local flavor to global exchange, simple ingredients to complex transformation. The journey from Kyokushin's temple to tables worldwide demonstrates how human ingenuity can take accidental discoveries and develop them into innovations that enrich lives across cultures and centuries. The dark liquid that first appeared in 13th century fermentation vats now seasons dishes from Tokyo to São Paulo, from Stockholm to Cape Town, carrying with it the concentrated essence of time and transformation, patience and possibility. The global embrace of soy sauce represents more than just culinary adoption. It reflects humanity's capacity to recognize quality and value regardless of cultural origins, to adapt traditions to new contexts while preserving essential characteristics, to create connections across vast distances through shared appreciation for flavor and craftsmanship. In every kitchen where soy sauce enhances a meal, the ancient compact between human intention and natural process continues, one delicious drop at a time. Sleep well, there are more stories to come. So that's the story, not polished or glorious, but patient, fermented, and real. From Kyokushin's accidental discovery in a mountain temple to the global embrace of liquid umami, from simple soybeans meeting salt to the complex alchemy of time and transformation. If you're still with me through these quiet centuries of fermentation, thank you for sharing this slow journey through wooden vats and patient seasons, and letting the ancient rhythm of Koji and moromi drift across your night. I hope somewhere in the salt brine and settling mash, in the careful stirring and seasonal waiting, you found a little peace, the same peace that filled those temple halls where steam rose from cooking beans, where master brewers learned to read the invisible language of beneficial microorganisms, where time itself became an ingredient as crucial as any grain or crystal of salt. If this helped you sleep, or if you simply enjoyed the stillness of centuries-old fermentation halls, please like the video and subscribe if you'd like more slow journeys through the hidden histories that flavor our world. Let me know where you're listening from, wonder you'll ever taste soy sauce quite the same way again, knowing the patient transformation it carries in every drop. Tomorrow we'll wander somewhere new, maybe 2 other fermentation chambers where different grains surrender to different microbes, maybe 2 other accidents that became traditions, other discoveries that crossed oceans, maybe even 2 other temples where patient monks stumbled upon flavors that would outlive empires. But still slow, still true, still waiting for someone to remember the quiet alchemy that transforms the simple into the sublime. Until then, sleep well. There are more stories to come.